So in this remove function is based on the index, not based on the object. It will not even verify which type of object it is which you are going to remove. So when you will store here, this is 0th index, first index, second index, third index, fourth index. Now if I say here remove of 4, it will not verify which type of object it is or what object it is, what it is containing. No verification, directly remove this element. Okay, so this is a new remove, and here remove with object, remove with int. One more remove we have seen with iterator. Iterator function is having remove, but this is not taking any argument. Okay, this 3 remove, remember very clearly, this remove is not taking any argument. Why? Currently where the iterator is pointing, that object is going to be removed. This remove is in particular index. Whatever index you give, that is going to be removed. This remove is first occurrence of matching object if available. If not available, no remove. Here, if not available this index, it will give exception that particular index is not available. Here, wherever currently the cursor is pointing, that object is going to be removed. So these 3 remove method. You try this first. So I have here currently in the list how many elements it has. Hello first, right? I'll say remove first index, means ABC has to be removed. I'll not give remove ABC. If I first write list dot remove with ABC, which function it is? This function is from the collection interface, but I don't want this. Based on the index, it has to remove. So you have to say here list dot remove of first index integer value. Okay, and after that again I am printing list. Run it. Fine. ABC is removed. Okay, this is based on index. This is based on index. Now, how many maximum index can be here? What can be the maximum index? 0, 1, 2. 2 is the maximum index, right? If I say list dot remove of 10th element, which is not present, index is not available, right? It isn't. No index out of bounds exception. Index out of bounds exception. It is an exception. Okay? It is an exception. But this remove, if I tell remove high, high is not present. High is not present. Run it. No exception. It is not removing, no exception even. But when it is index wise, when the function is from the list interface, and if the index is not present, index out of bounds exception. Similar like string class, string index out of bounds exception. But here it is index out of bounds exception. That's it. Right? Index out of bounds exception. This you remember, okay? This is remove, and this is also remove. Now, one more difference is there. That is, this remove return type is Boolean. If it is removing, okay. If it is removed successfully, it will give true. This remove return type is int. Which index is removed? That index it will return. Actually, it is not required, right? If it is not required, it is fine because you don't know. Sorry, it is not index int. It is of type not int. Objects. The object which is removed, that is going to be returned. For example, here I have said remove 1. In 1, which index it is? Index is at that time ABC. Here we have added already hello. So index 1 is ABC. So if I collect this remove value, it will give ABC, means ABC is removed. So this is another difference in this. So you write it like this. Say, I'm writing here obj list dot remove, and I'll print here obj also. Obj. Run it. Remove object. From here, ABC is removed. This is returning, and here no ABC. ABC is removed. So when you are using this remove function with index, this remove function with index, this returns the object which is removed from this particular index. This removes the object and it says it is just removed or not, true or false. If matching object is found, removed, first occurrence, and says it is removed. Matching element not found, false, not removed. Difference is iterator is also having removed, right? Iterator is also having removed. What it will return? Iterator remove is not returning anything, it is void. For example, create an iterator. Iterator id is equal to list.iterator. This is the iterator. And in that iterator dot remove, it is not returning anything. Why it is not returning anything? The return type of this iterator, this remove function is void. Means it is 100% sure it will remove. Which object? Current object. Where currently iterator is pointing, that object is going to be removed and return type is void. In this remove, particular index element is going to remove, return type is object. Which object is removed? That object will be returned. In this remove, object matching, first occurrence matching object will be removed and it will say just removed or not. Okay. Here no exception. Here no exception. It will 100% sure it will remove. If it is not remove also, it will not give any exception. How it is? Okay, we'll see. And if this is not able to remove, it may give an exception which is index out of bounds exception. Here chance is there, okay? Index out of bound exception. Here no exception. No exception. Here no exception. It may remove. Or if you just say remove, it will remove. It will 100% sure it will remove. In some case, it will not be removing. How it is? Say, if I tell like this, while it dot has next, object obj is equal to it dot next. Then object will be stored into obj, right? And after that, if I just say it dot remove, it will remove 100% sure, no exception, it will remove. But if I give a condition, if obj equals to something, then remove. Then it may remove, it may not remove. But without condition, if I directly say remove, it will definitely remove the current object, no exception, nothing. If you want a verification of, if you want to verify a condition before removing, then you can write like this. In this case, it is not that it is not going to remove. If the condition is false, function is not applied at all. If you apply the function, it will 100% sure it will remove. But when I verify the condition, what does it mean? It means if the condition is not matching, don't apply the function. But somehow, if you apply the function, it is 100% sure it is going to remove the current object. Okay. So this is 3 remove function. One is collection remove function, which is very, very important you need to understand. Another remove function is list interface, which takes an index and returns the current object which is removing. Remove function in iterator, which removes the current object 100% sure. No exception. Index out of bounds exception may be. No exception at all. If it is removing, true, not removing, false. No exception. Right? So now when you are developing any application, you need to be careful that if you are applying this remove, you need to write this in try and catch if you want to be a good developer. This remove function, wherever you write, chance is there that it may give an exception. And that exception is unchecked. So better you always write this in try and catch. Okay? Always write this in try and catch. But if I use this remove or this remove, no need to write in try and catch because these two 100% sure will not throw any exception. Okay? But this chance is there. So these you need to write in try and catch. Okay, so this is one remove function. Next. In the collection, we have seen clear. Clear function. What it will do? Entire collection will be terminated. But in this case, we have discussed another important point. If the collection is having 1000 elements, it will not delete all these elements one by one. What it will do? Entire collection is dropped and this will create a new collection to save the time. Okay, clear function works like this to save the time. instead of deleting from this collection one by one, directly drop this collection, which is having 1000 elements, create a new empty collection, assign this address to this with the same reference variable. Okay. So this is one clear. For clear function, in the list, no new function is given. The same function has to be applied, which is inherited. Okay. Inherited clear function has to be used. Next, add all. In the collection interface, you have seen here, add all. This takes a collection type object. This takes a collection type object. But where it will add? At the end of the current collection, right? At the end of the current collection. Now, for these, one function is given in the list, which is add all only, add all, but it takes two arguments. What is this two argument? First one is int or index, another one is collection. Okay. So int is the index from where you want to add, and collection, which collection you want to add. Okay. So this add function is add all in the list. I'm not going to apply this again. Okay. You try. Add all adds all the collection at the last of the current collection. Current collection is status collection. So this collection, all the elements are going to add at the last of this. But in this, you have a choice. You can say, okay, this collection has to be added to the current collection, but it is not at the last, at the beginning, or in middle, or the 5th index, 7th index, somewhere, wherever you want, specify the index. Okay. This is add and add all. Next, contains all. Here we have seen contains all. Contains all. Contains all of collection. Collection type object. So for these, here no new function. The same contains all inherited function you can apply. Okay. Inherited function you can apply. Fine. Next, remove all. Here I'll write in top of this. Okay. Remove all. Remove all of collection. Matching element has to be removed, right? Matching element has to be removed. For this also, in this no function, you can apply the same inherited remove all with the same argument collection. Then next, we have seen retain all. Retain all function with collection. Non-matching element. Retain all with collection. Here also no new function for this. You can use the same retain all. So what are the common functions we have seen? Add, remove, add all. These three newly overloaded function, which is inherited from collection that is present in the list. On top of that, new version of these three function is added in list interface. Add, overloaded, remove, overloaded, add all, overloaded. These three overloaded function with collection and list, overloaded function in list. Okay, which returns an object. Get means a particular object. Till now what we have seen, I have collection. If I want to get the element one by one, what we did? Iterator. We have used iterator to get the collection element one by one. Right? But I want a particular object, I want. For this, in collection interface, you don't have any method. New method is given in the list interface, get. It gives that particular object. So what we'll do here now, I'll put all this in comment. These are commented. And now, print the collection first, check it, what other things are there. So you have these three. Even remove also I'll comment, okay? Commented but not saved. Right, now you check. You have ABC 99 and 23, right? I'll add hello also. Add zeroth index. And again you check. Now you have these elements, right? The elements. Now from this, I want to get a particular one. You have hello first, then you have ABC, then you have 99, you have 23. This is the collection containing now. I want one particular object. So what you can do is object obj is equal to list.get. This get function is not present in collection interface. Okay, it is a newly method defined in list interface, and I want to get the third index element, and I'll just print obj. Now, what is the element in third index? First, you will have hello, then you have ABC, which is first index, 99, second index, third index is 23. So this obj has to print, object has to print 23. You remember that this get is not removing, okay? It will just give the reference. It will not remove it from the collection. Now run it. Okay, it is giving 23. Fine. Right? This is get. But if I write it like this, so this again I'm writing. Index is 13, which is not present. Now run it. Again, index out of bounds exception. Right? Index out of. So in remove also, when you are giving index out of bound, which index is not present, which I have seen here. Right? If index is not present, index out of bounds exception. Get also, if index is not present, index out of bounds exception. So this is not okay. This is also not okay. So this is get method. Get method, okay? From a particular index when you want to get an element. Next. So this is get function. Next is index of. This is similar like string class, how we have discussed, means all these are similar like almost string class functions. So next is index of. Index of a particular object. And this returns the index which is of type integer, okay? Index of. Means maybe you will have multiple occurrence for a particular object. Say you are adding some other again adding the same collection, okay? Same elements again adding 2-3 times. Like this. After that, printing the collection again. And it is list. Run this. This. So 99 present so many times, ABC present so many times, 23 also in the same way. Now if I say index of a particular object, 99 if I tell, say int return type, index is equal to list dot index of 99. And print the index. It gives the first occurrence of, okay, first occurrence of the matching object. It is 2, means this is 0, 1, 2. But how many times 99 is actually present? 99 is actually present so many times. First occurrence it is giving 2. Okay, first occurrence is 2. Means that the second index 99 is present. So this is just index of. Simple. Same way, you have last index of. Last occurrence, okay? It will give the last occurrence. So this is last index of again object. And again this returns the index, which is of type int. So if I apply here last index of 99, assume index is list dot last index of 99. And then again I'm printing index. I run it and check. Last index of 99 is 8, means it is this one. Count it. This is 0, 1, 2, 3, 4, 5, 6, 7, and this is 8. Right? Last index of 99. If I give something like this, say last index of object, right? Any object. So I'll give here Java, which is not present in this collection. Now you run. It is not an exception. It is giving -1. -1 means it is not present. Okay. If the object is not found, then it is to say, okay, it is not present. It is by using -1 means the object is not present, and it is not giving any exception. Okay, it is not giving any exception. Fine. So this is index of and the last index of. Next is very important one, sublist. Sublist. This returns an object of type list. It should be list. Object of type list, which gives you a sublist. But you have to tell here, this is exactly similar like substring. You have to give to int and int. From where to where you want the sublist. So assume, if you just run this program first, run it, and it is this. Till this I want a sublist. From 99 till ABC. This I want. Okay, sublist. So the index should be hello 0, 1, and 2, right? From 2 till 3, 4, 5, 6, and 7. Till 7, right? 2 to 7. 2 to 7. It has to give. So you give the same sublist 2 to 7. Take another list. Sublist, assume I'll give the name, and list dot sublist of 2 to 7 it has to include. And I'm printing the sublist. Run this. 2 is 99, okay. Till 7 means it has to include ABC, right? It is not including. Means how it is? Including the first index, excluding the last index. Excluding the last index. So if you want it till 7, you have to set till 8. Till 8. Okay, because it is length -1. So you have to say here it is similar, like exactly similar like the string, right? String, substring, if you do, it is similar like this, including first index, including the last index. So it is this. Okay, this is sublist. After creating the sublist, if we do something like this, assume in sublist I am adding a new element, sublist.add Java. In sublist, added Java. Now print the sublist and print the actual list also. Print the list. This is the actual list. Now will it include or not? Run it and check. After adding Java, it is added here. And this is also added. In this main collection also Java is added. Means what? When you say sublist, it is not actually another sublist. This actually just gets a boundary. Just gets a boundary. So if you do any modification in the sublist, this modification is reflecting in the actual list also. That you remember clearly, okay? This modification reflects in actual object also. But in case of string, if I get a substring and if I do modification, in that it is not reflecting in the actual. Why it is so? Because string objects are immutable. Collection objects are not immutable. These are mutables. And in a string, when you do sublist, it creates a new object. But here it is not a new object, it is the same object. Okay? So whatever modification you do in the sublist, that reflects in the actual list also. Right? Actual list also. Okay, fine. So this is sublist. Now, when I'm creating a sublist, if the index, if I give from 2 to 18, index is not present, which is not present. Now you run it, what will happen? Index out of bounds exception again. Index out of bounds exception again. Index is not present, okay? So same also in string also. If you do this in string index out of bounds exception. Here it is index out of bounds exception. So this you remember. So totally you can say like this. Wherever we are using index, if it is this, if it is get, if it is remove, if it is add with index, wherever you are using index to perform any operation, and if the index is not present, then you are going to get index out of bounds exception. Totally you can remember it like this. Okay. So this is sublist. Next is set function. We have seen one more, some that I'll remove. List, okay, list function I'm writing. It is set, which is having index and which is having two argument object. It has even a return type, which is again of type object. This is set. What is the use of set? We have seen add with object, which is from collection interface. We have seen add with index and object, which is from list interface. In particular index, the element has to be added. What will happen to the remaining element? Here, if I add an element at this place, okay? If I add an element at this place, what will happen to the remaining element will be shifted, New element, say here I am using JSP, remaining element will be shifted, right? This is that. When I'll say set in a particular index with an object, difference is, if I say set at particular index, say 1, in first place, what element is there, ABC, that is going to replace with this new object. This is the difference. Okay. Set will replace the existing object in the existing index, but add, what it will do? Add will not replace, remaining element will be shifted. It will create an empty space here and the new element will be added in this place. So this is the difference between set and add. Set and add. Add return type is void. After shifting the element, add will place this object here and it will return empty, nothing. But what set will do? Set is replacing the object in a particular index. It is not shifting. And the object which is replaced, 99, say in 99 I am placing JSP. JSP will be placed in place of 99 and 99 will be returned. Which one is replaced? That is going to be returned. Which one is replaced? That is going to be returned. Okay. So this is set. Now you check our current collection and here we'll perform some operation. For example, the current collection is this list, right? And run it. It is having hello ABC 99, something like this, right? Now if I say set at first index JSP, what will happen? This will replace with JSP and this ABC will be returned. Okay, replace with JSP and ABC will be returned. So now if I say list dot set with first index and it should replace with JSP and the return element I'm storing in obj. This. So obj should be, if I print obj should be ABC, and again if I print the list, then instead of ABC it should be JSP, correct? ABC is replaced with JSP and ABC is returned. So this is set. Remember this, okay? Set will replace the existing element in the particular index, but add is not going to replace. Add will shift the element. It will create an empty space. In that empty space, this element is going to be added. This will replace. And which element is replaced? That element is going to be returned. Okay, that element is going to be returned. So this is set. One more important function is remaining, which is list iterator. Iterator you can apply. Here we have seen somewhere this iterator. You can apply directly here, okay? Here also directly you can apply iterator. This gives the iterator of the file. Another important function in list is list iterator. List iterators, which returns an object of type list iterators. List iterators. Right. Come back to our diagram. Is this? And here you can see list iterator is this one. List iterator. This is a type of iterator. When you will get iterator? Iterator you will get when you will apply iterator function. Where is iterator function? In the iterable interface. When you will apply iterator function, it returns an object of type iterator. Right? But in the list you have a function which is list iterator. This returns a function of type list iterator. Okay. So this we are going to discuss in the next class. This we are going to discuss in the next class. Now, what we will discuss here is, I'll remove all this. This function will come back in the next class, okay? So come back to this diagram again. Here, what we have seen, iterable, which is having iterator function you have seen. Collection interface, which is having some function you have seen. List interface, which is having some function you have seen. So all these functions, whatever you have seen in all these three, can be applied in array list, can be applied in linked list, can be applied in vector, can be applied in stack. All these four are concrete class. Okay. Apart from these functions, these concrete classes are not having extra functions. These functions only have to apply for this type of collections for any operation. So almost all the operations we can perform by using those functions, as we have seen just now. But why array list, why linked list, why vector, why stack? All are storing collection object only. You can use array list, you can use linked list, you can use vector, you can use stack. Anyone is fine. But why this 4 is given? Okay. So all the operations till now we did by using array list. You can do the same for linked list also. You can do the same for vector also. You can do the same for stack also. One important point we have seen here, for vector and stack, you can apply enumeration because these are legacy. But array list and linked list, enumeration you cannot apply. What you can apply? Iterator, we have covered already. List iterator, we will see in the next class. Right? These two you can apply for iteration. Okay, list iterator will come back to next class. Why these 4 classes are given for the same operations? Vector, stack, array list, linked list. That is depending on the type of operation which you are performing. Vector and stack you should not use anyway. We have seen earlier some example you have seen on vector and stack. And these two you should not use currently because these are legacy. And legacy, it has one more problem, that whatever functions we have seen so far, add all the functions from this, all these functions in these, when it is written, overwritten, these functions are synchronized. So now if I create a vector and if I say add, this add function will be synchronized. If I create a stack object, if I say remove, this will be synchronized. Now what is the problem? The problem in this is, if I have a vector object, say one collection, which is pointing to an object of collection, but this is of type vector. If I say here add, one thread is saying add one object, another thread, two thread. This is one thread. Thread is pointing to this object, which is having a collection, which is pointing to this. You have one more thread, th1 and th2. th2 is, this is thread object. This is again having collection. That is also pointing to this, right? And both is applying collection.add with some object, This is also applying add with some object. And the add function for this collection is synchronized. Synchronized. Now what will happen? This object cannot be shared by both the thread at a time because this is synchronized. And this is synchronized in these two because the legacy class is designed like this. For these two, legacy classes are designed like this, that all the functions will be synchronized. But in these two, these are not synchronized. Okay, so this is multi-threading is not possible. In this multi-threading is possible, right? So because of that, these two no use, fine. So these two no use, fine. But internally, vector and stack, how collection will be created? How collection will be created? If you create a vector or if you create a stack, internally it creates an array. Okay, array something like this, like in first class what you have seen. In an array, internally it is growable array. It increases the size automatically, and how it increases that also you have seen in details. It creates a copy every time when the space is over. Okay, it creates a copy every time when the space is over. Right. So you should not use because these are synchronized. But that synchronization problem is solved in array list and linked list. Fine. In array list and linked list, the synchronization problem is solved. But why still two? Why still two? Because when you create an object, collection object, by using array list assume I'm creating an array list object in the collection. So this is one collection which is pointing to a collection. Then how it will be? Internally it will be an array. It will be an array. Assume some element 10, 20, 30, 40. Like this, it has 1000 elements, right? And I'm using add function collection.add of second index 99. Means what? This add function is from ListIterator, okay? So this 99 should not add at last. It should not be here. Where it should be? Second index. This is 0, 1, 2. Means from 30, remaining almost 1000 element has to be shifted. This place should be empty, and here it should come 99. Right? So this is a big problem. Shifting, it will take so much of time. Shifting takes so much of time. So this data structure is not okay for this type of operation. Instead of that, what you can do, you can create, say, first element when I'm adding this is 10. Second element is not array, it is another memory somewhere. And there I am adding 20. Sorry, here it is 20. And this object address 2040 should be stored into this 2040. This point here. Okay. And where is collection? Collection is this. It is pointing to the first element. Another element when I'll add, not in an array, it is like this. So here I am using 30. And 30 should be 30 address 2060. This should be 2060. This is memory address. So in each of this, this is the element, memory address, element, memory address, element, next memory, but still it is not there, okay? So I am adding one more element, assume. When I'll add one more element, it will be added somewhere in the memory. So 40, this address 2080, this should be here 2080. It is pointing. So this is another data structure. What is array? Array is continuous memory location. Now assume in this collection, when I will say collection.add 299, what will happen? Assume this is 0, this is 1, this is 2. In the second place should not be 30, it should be 99. So what it will do? This link will break. It will not shift. This link will break. Somewhere in other memory, 99 will be stored. This address is 3080. This will be updated here 3080. It points here. What about this? This will be stored into 2060 and it will point here. Means one break. In middle it will break the link, add a new element here, and this should point into. If it is adding, now if it is having 1000 elements here, 1000 elements, shifting at all, shifting is not required at all. In middle only it will break the link and it will add a new element. So this is the better idea for this type of operation. Right? This structure is not good. This structure is good. So this is linked list, okay, doubly linked list. It should be a doubly linked list, like this, both way. You can traverse in both the way. Right. So this is array list. It creates an array internally. This is linked list. Linked list. It creates a doubly linked list internally, like this. For which type of operation? Add operation. For add operation, array is not good. But for add operation, linked list is good because shifting is not required. But it has problem also. What is the problem? Suppose I want to search the 999th element. And I'm saying here, get of 999, which should return the object, right? Which should return the object. This get method is from the list interface you have seen. So the memory is not continuous in this. So what this get function will do? First it will go to the first. Is it 999? No. Go to the next. Is it 999? No. Go to the next. Is it 999? No. Next. 999? No. Next. Till this, it has to go to till this many space. Means this many nodes it has to traverse, and at one point it will get 999 and it will return. Sorry, it is yes, it will give here 999. Whatever value is 999. Maybe this is 999 is index I'm considering. Okay, maybe value is Java, so it will give here Java. And this address has to go. When you will, so this is search, right? Search. So search operation, when you are performing in the linked list, it has to traverse to all the nodes and it will get the element wherever and it will give. If it is not found at the last node also, then it will say, okay, object is not present or some error. But if I do same operation here, collection dot get of 999, it is no need to go to the first 0th index, second index, third index, fourth index, not required. It has index and it will directly reach to the 999 because it is an array. It is continuous memory location, directly reaches to the 999 and it gets that, returns that. In this, what it has to do, because it is not a continuous memory location, it is in different memory. So it has to go through the nodes, traverse. It has to traverse from the beginning till the end, and wherever it will find the matching element that has to be returned. So adding is good for this. Sorry, adding is not good for this. Searching is good. Here adding is good, searching is not good. Here adding will take less time. Here adding will take more time. Searching will take more time. Searching will take less time. Okay. So this is searching is good. Here adding is good. Adding is good. So because of these two, this is array list and this is linked list. Sorry, just array list and this is linked list. This is array list, this is linked list. Now, depending on your requirement, either you go for array list or you go for linked list. Functions, all you can apply. All the functions you can apply. Now, which type of operation you will perform frequently? Based on that, you have to find out your corresponding collection type. Which collection you have to use? Means this is the internal data structure of array list, and this is the internal data structure of linked list. Internal data structure of array list and internal data structure of linked list. If it is clear till this, now it has one problem. What is the problem is, when I am saying index of, and if it is array list, index of 99, okay, because it is array list, it will have index and it will go to the 99th position and it will return the object. Index is there. But in node, these are nodes, not continuous memory nodes. And I am saying index of 99, last index of 99. Or when I am saying set first index, or when I am saying get in this particular index, how it will work in this? Because these are not having index. Nodes will never have index. Nodes, one node should contain one element and the address of the next node. Each node has to contain one element of type object and the address of next node. no index concept in this. So this is one in the node, this is another node, this is another node. Memory can be anywhere. Memory can be anywhere. So in this index is not there. Then how this is working, how this is working, how this is working. Because these we are giving index, right? Even Sublist also are giving index. How it will work in linked list? Array list is working fine because internally it is creating array object type array, which is good. It is having index. But in linked list, how it will work? Because of this reason. But assume if I just apply add of high. If I apply add here, it has to be at last. Here it should be high. Okay, no problem. If I apply add here, high, then also no problem. At last, it has to create one node. It has to apply here high. This address has to update it to this. That's it. So it is fine, no problem. It is fine. Add function is working fine. Means you can say the add function implementation for array list and add function implementation for linked list is same. No change. But the index of this add function, this is inherited from the collection interface. Okay, collection interface add function is same for this and same for this. But if I say like this, add of third index high, and in this also add of third index and high. This index will work here fine, but this index will not work here. So the implementation of this add function for the array list, for the linked list, should be different from the implementation of add function for the array list. The same add function implementation will not work for array list, will not work for linked list. Add function with index has to be different. Index of function for array list should be different. For index of for linked list should be different. So you can say for both type of collection, some function implementation can be same, some function implementation can be different, right? Should be different. Because of this reason, come back to the diagram. Because of this reason, I'll clean it first, okay? Because of this reason, this abstract class in middle is implemented, this one. Now, for both the type, for this one and for this one, some function implementation is common, which is inherited from collection, inherited from list. From both of these, whatever function is inherited for array list, whatever function is inherited for linked list, some function implementation is common for both of these. So those function implementation is given in the abstract list. Common implementation. But for some function, for this implementation should be different, this implementation should be different. So those functions in these remains abstract. So because some functions are abstract in this abstract list, so this is declared as abstract. So you cannot create any object for this. Okay. So the function which is not common, this remains abstract in abstract list, and those functions separately implemented for array list, separately implemented for linked list. Okay. So this is again very, very important question. Why abstract list is required in middle of list and these concrete classes? This abstract list is required because the common function implementation of collection method and the list method is implemented in abstract list. But the function which is not common, those remains abstract. So if a class contains an abstract method, the class also must be declared as abstract. So those function implementation again given separately for array list, separately for linked list in their concrete classes. Clear with this point, you guys, I hope. If you are not clear, okay, you ask me. Otherwise, I'll continue.
Sir, please repeat, sir. Abstract list.
Abstract list. So in this example, what we have seen so far, some functions, for example, see once again, for example, if I create an array list object, how it will create, this is array list object is created. Internally, how it is an array. It is an array. Internally, it is an array. If I create a linked list, then internally how it is, it should be a node. I'm giving in this way, assume, and it should be a node. Node is this one node, another node, another node. All this is linked somehow, right? Then one more, this is here, something like this, right? So if I perform simple add operation, add high, this is common here, at last high will be added, add high, there also last added. Last here somewhere high will be added, right? So add function implementation for these, both of this, if it is array list data structure or if it is node data structure, this add function is same. So this add function implementation will be given into this abstract list because it is common. Next, if it is add of 1 and high, so it is not 1, it is 2 and high. Then here 0, 1, 2, index is there because it is an array, index is there. So the second place high will be placed, remaining element has to be shifted. This add. And here if I say add of 2 and high, 2 is the index, but in node you don't have an index. So these 2 as an index will not work here. These 2 as an index will work here because this collection is having index. These 2 will not work here as an index because node is not having an index. So the implementation of add function for the array list should be different from the implementation of add function from the linked list. So these add function, and this add function is from where? This add function is from where? Add function is from the list. And it cannot be implemented in this abstract list because implementation should be different for this, should be different for this. So that add function with index and object remains abstract in the abstract list. So this list is abstract. But the add function, which is having only object, is implemented in this. So the abstract add function for array list should be implemented here, for linked list should be implemented here. And because of that, so here what we understood is the common functionalities for array list and linked list are implemented in abstract list. But which is not common for array list and linked list remains abstract in the abstract list, Because of that, abstract list is designed in middle so that common functionalities or common method implementation for array list and linked list can be centralized. No need to write repeatedly. But which are common, which are uncommon, what about those? That remains unimplemented. That will be implemented at this place and at this place. Because of this reason, because these are unimplemented, so this should be abstract. So this is the use of abstract list in middle. Clear with this, everyone? If any question, ask till this. No question, right? Now, come back to this again. Now I understood that here index will not work. Because of that, implementation is given separately. Because index is not going to work. If index is not working, then how this function is implemented? Add function, how implemented in array list? Because here no index. So what it will do is, when you will create an array list, and when you will add one element, it will have a count variable. First time count is 0. And that count means how many nodes. Count means how many nodes, number of nodes. First time it is 0, no node. When you will say hi, count is 1. When you say next add, next hello, count is 2. Next add, count is 3. Next add, count is 4. When you say add function with two index, it is not treating as index, it is treating as the number of node. Okay, it is treating here as the number of node, not the index. But here if I say high, 2 and high, this 2 is treating here as an index. Very, very important. Okay, remember this. In array list, when you will say add with any index, that index will be treated as index only. For example, index of 99 will be treated as index only. Last index of 99 will return the index only. But the same operation, if I say in the linked list, last index of 99, what it will return? Node number. Node number will be returned, not the index. In this, if I say last index of 99, node number will be returned. Node number, okay? So if I say here set of first JSP, in case of array list, this one is the index, first index. The same if I apply in the linked list, this will not be considered as an index. This will be considered as the number of node. This is very, very important. Okay, this is very, very important. So you should remember very clearly, when it is an array list, index is index only. When it is linked list, index is not index. Index is number of node. Okay. Internally, it maintains a count from where it gets the number of node, and it goes to that node particularly. Okay, it goes to that node. Another important point here, what you have to remember is, here searching is easy, but modifying, adding or deleting is expensive. Here, adding or deleting is not expensive, but searching is expensive. Okay. So internal data structure of array list is array, one-dimensional array. Internal data structure of linked list is node. Okay, node. So this is the list interface. This part is done. This is done. One small is remaining here, which is from here, the method is ListIterator. That I will going to discuss in the next class, which returns an object of type ListIterator. That I will discuss in the next class tomorrow. Okay, these two you should not use because legacy and because all the functions are synchronized. Both internally uses array. This uses internally array, one-dimensional. This uses node. This is abstract because some functions implementation is same for both of this. Some function implementation is not common for both of this. So uncommon functions in this. Uncommon functions from where? From the collection interface and from the list interface. The function which is not same for both of this here remains abstract. So this class is declared as abstract. But the function which is common is implemented in this. Because of that, this class is taken here so that the common function implementation can be centralized. Okay, can be centralized. So this is collection. List part is done. Only this is remaining. That we'll see in the next class, and we'll start with this section. So if you have any question till this, you can ask.
So for vector,
Come again.
so for vector and stack class,
Yes.
we should not use that iterator and list iterator.
Yes, you should not use iterator and list iterator. But now you can use, okay? Now you can use. Why you can use? See the structure. Where is the list? List is in the iterator. Here list. Where is the list iterator? In the collection. This is list iterator. Now, iterator and list iterator is inherited to vector also, right? Inherited to stack also. So, iterator and list iterator both can be applied in vector and stack. Even for these, you can use enumeration also. So enumeration, iterator, list iterator, all three can be applied for vector and stack. But for array list and list, what are the iterator can be applied? Only iterator and list iterator. Enumeration cannot be applied because it is legacy. In vector and stack, these iterator and list iterator can be applied because the hierarchy is given in this way, because of hierarchy which is inherited. So you can apply.